All right, hello everyone. It's time again for Security Systems News Leadership Talks webcast series. This is Paul Ragusa. I'm the editor for the publication. I'm very excited to have Jumbi Edulbehram here. He's the Regional President Americas for Oncam. Hey Jumbi, how are you?
Doing very well, thanks, Bob. Hi, everyone.
And before we jump into the questions, Jumbi, can you just give us a quick overview of the company?
Sure. So Oncam is a manufacturer of 360-degree video technology, both for 360-degree fisheye cameras as well as 180-degree cameras. We make both the hardware and the software, extensively deployed in a large number of applications where you require total situational awareness, coverage of large areas of video.
Okay, good. That's great. And Jumbi, I know at ISC West we had a great conversation about analytics and how far they've come and how far they haven't come, and also AI and machine learning and how that factors into the whole equation. So I thought
Sure.
This is a great topic for us to talk about today. First, let's just get right into it. Why is AI and machine learning getting so much buzz lately in security?
Yeah, that's a great question. I've been kind of involved with the analytics stuff since, I guess, 1998, 2000, somewhere around then, when they were really starting to pick up in a variety of different applications. And what we realized, even to date with a lot of the traditional analytics, is that they have a very hard time interpreting real life. They have a very easy time following instructions, but they have a very hard time interpreting reality. So I'll give you an example. So, if you have in the security applications, very simple tripwire application where you're looking for people crossing a particular line, the algorithm works really well to tell you if anything crosses the line. But the issue is whether or not it's smart enough to figure out whether it's only humans or a bunch of other random stuff. Now, there are a whole host of applications where these kinds of mistakes either adds to a lot of false alerts or misses a bunch of stuff that they should have gotten. For example, the person is crawling on the ground. So what AI and machine learning do that's really exciting is that they actually interpret the world, the real world, in a much more robust way. So for example, whether the person is, literally flying, walking, crawling, sliding, whatever it is, they'll be recognized as a person. And unlike in the old way of doing things, where you'd actually have to tell the computer what to look for when you're looking for a person, in the new world of AI, you basically give the computer a whole bunch of examples of what a person actually is in many different, ways, shapes, forms, etc. And then let it decide from then on, when it sees something, whether or not it's a person. And turns out, even in the last few years, that, people have realized that that's a much better, much more robust, much more accurate way of interpreting the real world. That's why I think it's getting a lot of buzz.
Yeah, so it sounds like it's a fundamentally different way of analyzing video and data. Is that correct, or is it just a newer generation?
Exactly.
Okay.
No, it's absolutely a fundamentally different way of analyzing video and data. And then how it's applied is also fundamentally different in the sense that it could be applied by basically teaching the computer by feeding it a whole bunch of information, or in the true sense of, like, for example, a deep learning algorithm, which is another word that people use. You could simply provide the computer a lot of images, let it analyze all those images, literally pixel by pixel, figure out, what the changes are, and then make decisions based on what you're looking for after it does the analysis.
Yeah, it's very
cool. Does that make sense?
Yeah. Getting into the kinds of applications that are likely to benefit most from it, can we get into that?
Sure. Absolutely. So, there's a whole bunch. I mean, there obviously, if you even just look online, there's just a whole range of companies that are coming up with all kinds of interesting applications. So I'd say, different categories of applications. The first category of applications, I would say, are the traditional applications that people were trying to do with traditional analytics. When you apply some machine learning and artificial intelligence technology to it, you make them much more robust and accurate. And, the example that I gave previously for a simple tripwire kind of application is one of those. So if you take a number of those kinds of applications, apply an additional layer of intelligence, you just improve the accuracy. The other whole host of applications are around facial recognition, number plate recognition, sort of the specialty applications in traditional security. Again, with new technology, AI technology applied to them, those again become much more accurate and extensible to, for example, not just recognizing particular face in a crowd, but also classifying faces. So, for example, age, gender, ethnicity, all that stuff becomes much more realistic to do when, you can teach the computer through large data sets what all these different categories of objects look like. So that's a whole host of the other applications that this thing opens up. And then and of course, any kind of biometric, voice biometrics, image biometrics, etc., are very useful for access control. The third, I would say, bucket of applications are anomaly detection or incident prediction, which didn't really exist in the previous sort of world of the traditional analytics. So, for example, there are companies now that can analyze the changes in every pixel in every frame of video and then correlate that to changes in every other pixel. And once the computer looks at this data set for a while, you can actually go back and say, show me anytime an anomaly occurs in the general way these pixels are changing. So, it's kind of a little bit of back to the future, I'd say, because in the really old world, before even the new world of sort of motion-based analytics, people used to just do pixel change detection to detect, to do motion detection, very simple, basic motion detection. But of course, that would get flipped out with, lighting changes, etc. But now it's come a full circle where just analyzing pixel changes with large data sets, you can actually make some really interesting conclusions about what might be anomalous versus what's normal. And then, of course, when this kind of intelligence is applied, for example, to new technology of drones and robots, etc., then it becomes even more interesting because then these autonomous vehicles can go make some decisions and go into situations where you may not necessarily want to put people in harm's way. So, for example, one of the biggest applications for robotics initially, at least in the security defense world, was bomb diffusing, where you really don't want to send someone into a risky situation, you'd send a robot. Right. And if you think about in security, there are a whole host of applications where if you don't actually need to send a person in to a potentially hazardous situation, why would you not send a robot or a drone or something that can effectively make decisions that a human would make autonomously or even being controlled remotely and helped in, whatever task it has.
Yeah, exactly. That makes sense. Okay, now, moving, I know you touched on a few things that I wanted to see if we could get into a little bit more on, for example, the potential for things like business intelligence, operational efficiencies, and then even getting into some of the things you were mentioning, preventive security, anticipating failure of a system, for example, before it happens. I know you mentioned detecting anomalies. Do you see potential in those areas?
Yeah, absolutely. So, take business intelligence, for example. a lot of businesses I'll give you, in fact, there's a company very local to here that's applying artificial intelligence, for example, to go through large sets of video to figure out where a brand of a particular company occurs and in what situations that brand is actually used or displayed, etc. And, companies are very interested to see, how their brand is used, abused, misused online. And they can now finally do that, because machines are capable of ingesting large amounts of information. That's a very simple example. A lot of examples, obviously, in, retail that, again, traditional analytics kind of hit a wall in the sense of they could only collect information that we knew that we wanted to collect, and we just, wanted to program a computer to go collect that information for us, right? So, for example, I want to know how many people go through a particular aisle and what normal traffic pattern looks like, and if for some reason, traffic in that aisle suddenly goes down or goes up beyond a certain limit, I want to know.
Yeah.
But that requires a lot of pre-configuration, pre-knowledge, pre-setting of stuff that, takes a lot of time and effort. Now, if you, with the new world of, AI and machine learning, you put a camera and say, observe what goes on, and then tell me if there's anything there that is anomalous or an incident happens which doesn't usually occur, I want to know. Or take for another example, again, in loss prevention, threat mitigation, etc. Humans only know to detect stuff that they've previously seen. But in an example of trying to detect a terrorist in a large crowd, which is, I would say like a holy grail of, video surveillance, looking into a large crowd and trying to figure out, if there's some threats there. Again, it's very difficult even for observers to look at a crowd and try and figure out if there's some anomalous behavior that, compared to what the norm might be in a large train station or a large airport.
Right.
But technology is now available, which can just literally watch for days, weeks, and months, everything going on. And if an anomaly does occur, it can flag it. Now, one issue with that is when it flags the anomaly and says, look, I think this is something that you should look at, machines don't always tell you back what it recognized that, made it think that it was an anomaly. So,
okay, that's interesting.
Yeah, that is an interesting sort of, I guess, fallout from machine vision when, machines start figuring out on their own using some of these deep learning techniques, what is anomalous or what is of interest, etc. You don't always get that information back to say, okay, because machines could have factored in 1,000 different things, right?
So you don't know how they got to that conclusion. Is that what you're saying?
Exactly. You don't always know how they got to that conclusion. So, to some degree, you just have to trust them and say, okay, they're making some decisions that go way beyond what we programmed them to do, because they're looking at a whole host of things that we necessarily haven't even told them. For example, this actually came up recently in one of the applications. The computer, apart from looking at the people, the crowd, and stuff like that, was also analyzing, lighting, shadows on the wall, all kinds of stuff, right? And to correlate what's going on, for example, in a crowd to what might be going on in terms of lighting outside the window or shadows or whatever, right? Humans wouldn't necessarily think of programming that and looking for certain correlations. But computers will do that. And if they come up with a correlation, they will flag it and say, well, look, this kind of light with this number of people, never existed. So this is something odd going on here.
Wow.
You know what I mean?
Yeah, that's really amazing. That's an exciting area. And especially for security, just the possibility.
Extremely exciting area. So there are companies that are trying to, in fact, do, like I mentioned, to detect lone wolf terrorists or to detect a student in a school that might be behaving very erratically as they're walking through the hallway. Again, stuff like that. I mean,
Right.
people used to be, with the traditional analytics, I'd completely agree that it was way too far-fetched because there was no way to pre-program those kinds of behaviors. But with AI, I really, really believe it's a matter of time and enough data that it'll take to do that kind of detection.
Right, and it's just amazing because it's always working. It's always learning 24 hours a day. It's massive amounts of processing going on. It's really fascinating.
Absolutely. Which, I should say that one of the key issues, like in the old world of analytics, the issue was how accurately you could program the computer using all kinds of smarts. In the new world, really the accuracy of this new kind of analytic depends on the quality of the training data. So, the larger data sets that you feed it, and it learns. So it does take time and effort to do that training. People shouldn't sort of think you just put it there and everything kind of happens automatically.
Right.
It does require some training because you can actually go back and when it points out an anomaly, you can tell it, look, I know you think this is an anomaly, but it isn't. And then going there forward from then, of course, it'll learn that that really wasn't an anomaly. But it does require that amount of training, and especially for, facial recognition, ethnicity recognition, or age recognition, etc. The larger the data sets you feed it, the more accurate the results would be.
Yeah, that makes sense. Now, how about with cybersecurity? Could it help with cybersecurity? It's such a big issue today.
Yeah, it's huge. And, I'm sorry I actually neglected to even mention that in the new category of applications that are popping up. Yeah, cybersecurity in many ways, online stuff is similar to the real world in the sense that, there's a normal amount and kind of activity that goes on. And then, something abnormal happens that you really want to detect, right? It could be a denial of service attack. It could be a whole bunch of different one of these, cyber security issues. And similar to the real world, where in the old world of cybersecurity, people used to have to pre-program these kinds of detection mechanisms, right? So you say, if my network, for example, network bandwidth goes up by X amount during this part of the day, give me an alert. Something might be going on. Or if someone, very simple stuff like if someone tries to log in using a wrong password 3 times, give me an alert because that could be a security issue, etc. Now, again, with the new world of AI-based stuff, you don't necessarily have to pre-program every behavior. The new cybersecurity stuff watches what's going on the network and people's accounts and people's computers, how applications are used, etc., and then would be capable of flagging anything that's kind of outside the norm. Of course, it can still detect all the stuff that you programmed it to detect, but going further than that, it'll actually detect stuff based on what it thinks is not the norm, which again is a step beyond what people might be able to program it to do, because it just factors in so many more parameters that you could possibly do before the fact. You know what I mean?
Yeah. So would you agree? I mean, AI needs people, and obviously people need AI, but do you agree with that?
Yeah, absolutely. AI definitely needs people in the sense that, you need to teach it and make it learn and give it enough information that it can learn by. And then, of course, which is the other issue, is you need to give it a lot of hardware to be able to process all this information. And the good thing right now is, cloud access, cloud services, cloud processing and stuff is again becoming much more prevalent. So again, compared to the old world, I remember in year 2000, 2001, to process 8 cameras, we would have to put a Mongo server in every location. Nowadays, processing everywhere from the edge in cameras and access control panels, etc., to servers to the cloud, there's just so much more available for these kinds of applications that they just become more affordable and readily deployable.
Yeah, well, Jumbi, we could talk about this topic for hours. I appreciate it. It's 20 minutes went by very, very fast. So thank you for joining me this week, and thank you everyone for joining us for another Leadership Talks. And thank you, Jumbi.
Thanks a lot, Paul. Thanks, everyone. Take care.